Okay, so let's jump straight forward to a brief introduction of who am I. My name is Shreethaar, and I'm currently doing computer science in UUM. And I am part of MCC alumni for last year. When it comes to CTF, I play with Reunion, and the challenges I mostly do are forensic and reverse engineering, and sometimes some occasional OSINT. So today's table of contents for the sharing session, we'll be looking at a case study, serial looker, and how they utilize DLL to perform their attacks, and some theoretical knowledge on why reversing DLL matters, what's DLL and how does it works. And finally, I will look at some codes in C, how to create a simple DLL, studying the structure with the PE file format, and some hands-on session with static and dynamic analysis. So the tools we are going to use for static and dynamic analysis is IDA and X32 debugger. And finally, if we have the time, for about 15 minutes, we will try to look at the CTF challenge. And this CTF challenge is created by me for BlackBerry CTF, happened around May. Yeah. And for the materials to download, you can refer to my GitHub. And you can just download zip folder or git clone it. Yeah. So without further ado, let's get started. Is there anything? It's fine. It's fine, right? Yeah. Oh yeah. Okay. First, the case study. So, SEO lurker is an APT. How this attack happened like 2-3 years ago. What their target is that they basically attack WinCSP users. WinCSP is basically Windows application for file transfer protocol, FTP and SFTP. So they have hijacked, basically compromised this website, gameweb.com, and within that website, they have this what you call a Google advertisement at the site, And once user click it, and it will install this wincsp.zip file, and once they unzip it, they run setup.exe, and then it will execute the DLL. The important thing here is that setup.exe is a legitimate application. It's been signed by Microsoft. And once the user run setup.exe, it automatically side loads the Python 3.11.dll. And of course, when you observe the attack chain, you will notice that it does install WinCSP. And here, this part, it performs a C2 connection and drop additional DLL. And at the end, it performs some persistence via scheduled task. So if you are an analyst, you have only been experiencing reversing exe all this while, you will only end up at setup.exe and thinking it's a legitimate application. You will just stop your analysis halfway there. So yeah, that's what makes DLL equally important as exe. So yeah, so you can refer and read more from this attack chain. Yeah, so and here comes the reason why reversing DLL matters. And for modern malware these days, they use DLL to employ various tactics. And if we refer here, this MITRE attack, they have suggested what are the sub-techniques being used for employ malicious activity using DLL. So we have DLL side loading, search order hijacking, redirection, phantom DLL hijacking, substitution. So these are the common sub-technique being used by APT, and below it, you can see the examples here. For example, like Dridex. Dridex uses they use side load to load DLL onto a legitimate Windows application. So for example, like Notepad, right? Once you open Notepad, it will side load malicious DLL. So yeah, that's generally how APT these days use DLL for their malicious purpose, and also common in reflective and process injection, which provides a more stealthy behavior and much more modular payloads. Referring to the pie chart at the right side, DLL is one of the top file types listed in Malware Bazaar. And okay, reversing DLL not just for malware analysis, it also can be more towards analyzing vulnerabilities that may lead to a supply chain risk. And also finally, understanding how application interacts with external libraries. For example, like game applications like Valorant, CSGO, it uses a lot of DLL in order for all the function being used. So that's the reasons why DLL is important as well. So now we come to the part where we have understanding what is DLL. DLL stands for Dynamic Link Library, which contains codes and data, just like how in EXE, but the difference is that DLL will be used by more than one program at the same time. So it contains exported function to be called by other modules. Modules here we are referring to an application, an EXE. So an EXE able to call exported function contained in the DLL. For an example, let's say you're writing a C code and you have declared a Windows API. And within your C code, you have your get open file name and get save file name. So when you compile and link it, right, it will include com dialog32 DLL, and in order to execute these functions. And dynamic linking allows a module to include only the information needed to locate and exported DLL function at load time or runtime. So the difference between load time and runtime, think it as you have a parcel and you load it on a lorry. That's load time. But once that lorry starts moving, it's runtime. So yeah, that's the analogy there. And the benefits of using DLL, it reduces memory and disk usage because the duplication of code in the binary itself being reduced. And for software development, the benefits will be promote much more modular architecture, ease of deployment and installation. But when it comes to security matters, yeah, you perform code sharing. Multiple applications can use the same DLL. For example, let's say you in Windows DLL user to DLL. If let's say you have different application that able to execute the message box at the same time, yeah, a different EXE can use the same DLL at the same time. Runtime loading, which also provides an opportunity to attack. And finally, DLL can be replaced or hijacked without changing the main executable. So here, understanding how DLL works, but before that, since we have to have a clear understanding what's the difference between static and dynamic linking. So if for static linking, the linker copies the object code from the library. Let's say you have a C code for the library, the whole object code will link it together with the final executable, and when you compile it, the whole chunk of it is bigger. The whole library code will be included in it. But for the dynamic linking, the linker does not copy the whole code, but however, it just insert the references or starts pointing back to the DLL. So in Windows, the file extension for static libraries are .lib, and for dynamic is DLL. And the main difference is that how it's being run. So the static library, when you link with the executable, it's during compile time. Compile, everything's together. But for dynamic, you only link it during runtime. Only when you call it, that's when it's being used. So here is a simple like graph for better understanding how linking and dynamic linking and static linking works. So let me change to dark mode for better view. Okay, there you go. Is it clear so far? Is there any questions? I mean, keep the questions coming in. Yeah, no questions so far. Okay, all right. So here we have two different linking examples here. So we have the main.c, and when for static, when you compile it, this is for Windows. CRT lib is for C runtime. So let's say you have a particular function for let's say printf or the main function. So C runtime would basically help to resolve this function and know when you run it, how to run accordingly. And linking will include the whole library code into it. So for those who have experiencing reversing EXE, and you sometimes will notice that CRT will be along with it. So that's how static linking works. So when you run static linked executables, everything in the library will be in the memory. However, for dynamic, you will be using CRT imp, and you only include the reference of the function from the CRT imp. And when you load and run, the main will be running first. And once you call the function that's been declared in the DLL, then it only calls the DLL separately. Here here is another graph for understanding how DLL being loaded with relative addressing, because DLL they are very dynamic in the sense where they rely a lot of ASLR and randomly slot in different memory region. So dark mode. So here we have an EXE and a DLL. So taking a quick look of EXE, how the process memory would be. So here normally we have the text section where the executable code will be there, and also function calls to the DLL. And within the EXE, you will notice import address table, and within that you will know which DLLs being reliant. So for example, let's say this EXE rely on let's say perform network communication, so you rely on WinNet DLL, right? And then function address of that DLL, so you rely on relative addressing, not absolute address. We will take a look what does it mean by absolute address and relative address. And finally, of course, EXE will contain that data section, static and global variables. For DLL, you will have your export table, function names, RVA. For the RVA, it will be used by the kernel in order to perform calculation, in order for EXE to use it. And we will take a quick example how the process works. And the code section, like for example, in DLL, you will declare DLL main, but for EXE is main, and it's position independent code, and it relies on relock. So taking a quick example here, we have the DLL. Okay, let's say we have a function A and function B, and the address is at 1000 from the base offset and 1005 from the base offset. And once DLL loaded, it will add base address with the RVA. And once you get this, it will be updated in the EXE at import address table. So EXE really relies on import address table in order to use the functions in the DLL. So when the EXE is being executed, it will first call the import address table entry, the address of it, and then able to jump to the DLL, and then the function being called. Yeah. So generally, that's how the flow works. And now we'll take a look at how along with the kernel, how DLL is being loaded. So the load flow of DLL. So far, okay. I'm 15 minutes in. Questions? No. Clear. Everything's clear. All right. Great. So, am I going too fast? No. Okay, great. Fast. Never mind. It will be uploaded in YouTube, and you guys can watch it back in 0.5 speed. So if you go very slow. Okay. So, okay. Here will be the cross section of how memory would be when you load executables and DLL, and then all of these applications are wrote randomly. And here we have the kernel. So here you will able to like realize, not realize, like having a visualization how executable have their own stack and DLL have their own stack. it's not together. Yeah. So here, when once the exe calls load library A, it will first import kernel-based DLL, and kernel-based DLL will calls anti-DLL in order to here this part over this region. Let me this region onwards, it's already in the kernel anti-DLL. So the kernel will then find where the DLL will locate and load it into the address space. And before it after it loads, it will perform the calculation of relogs. Like for example, like just now I say it calculates the IAT just now, yeah, and then it will resolve import names. And once the DLL is in the process memory, it will then call DLL main. And then when DLL main is being executed, it will. I need to remove this. It's not true. Okay, it will only call DLL process attached, not thread. I can't fix this, but it will straight away call DLL process attached. And later on, it will for the hands-on session when we debug it, you will notice that process attached will be called first before the exported function. Okay, and then once DLL is executed, finished, done, it will return back to the caller, which is a kernel-based DLL, and then it will return back to exe, and then exe, and then will call get proc address. So this is where you were able to call your exported function. So remember that load library A, DLL main will be executed, and for get proc address, it will be your exported function. And of course, it would require certain arguments for it to know which exported functions need to be loaded. Okay, clear? A new question. Where's the Q&A? Oh, hello. Okay, done. Yeah, you guys can use the Q&A. So give me a moment. I need to drink some water. My voice is become sore. Yeah, I mean, feel free to ask any questions if you don't understand which part. I will glad to repeat back. So yeah. Okay. All right. So now we have done with the theoretical part of understanding how DLL works. Here will be a code review, and for the code review, for those who doesn't have Microsoft Visual Studio Code, not VS Code, Microsoft Visual Studio Code, this one, yeah, not the blue one, the purple one, yeah. You guys can refer the slides, and for those who have Visual Studio Code, you guys can like understand the code. So at first we look at the DLL simple.dll.c. So yeah, can I increase? How do I increase? Is it clear for the size to see? Clear? Should I okay. All right. So in order to us to create a DLL in C or C++, but this code is in C. At first, of course, any code written in C, you have to declare Windows header. And in order for us to export the function, in order the exe to be used, we use this function signature, which is decospec DLL export. So what decospec DLL export will do when you compile it, it will save the name of the function into exported function. So later on, when we use IDA to reverse engineer, you will notice that all these functions will be in the export table. And here, yeah, we have add function taking 2 arguments and return the value of addition. Process data takes in a string of input and also the length of characters and XOR it with the value of 6F. And here it's a bit different. We have a callback function, and you will understand why it's being used this way. Here we will say get string, and here it takes a list of parameters. These arguments are a requirement of Windows, how they once you use callback function, you need to return back with a handle. Yeah. And here we have a declaration of message, a declaration function of message box. Basically, a pop up a message box and saying that hello from DLL. Yeah. So this is the exported function. Over here, here's the DLL main. Like same way, it needs to be declared how Microsoft wants us to be used. So this, I mean, their rules are very strict when you program application for Windows. And here we have a switch case. So reason here being is that whenever the exe calls, once that exe executed to call the load library function, it will straight away execute DLL process attach. And if there's none function being declared, it will ignore. But here we have a message box A, DLL loaded, and basically the same as this one. And when the detach, it will show another message box. So once when you load a DLL, you're able to perform an action, and once it's being loaded, after loading finish, you can able to process another action. But this function only can be used for Windows API function. You can't insert any user-defined function. And also bear in mind, since load library A is for loading DLL, right? And it's not recommended to have load library A to import another DLL. So what it's doing is that, let's say this is let's say when you compile this DLL, my DLL1, and once being executed, if let's say this DLL will call another load library, it will call another load library, my like take example as my DLL2, and this will create what we call is it like a circular? No, a deadlock. Yeah, this is what we call a deadlock. And some sort, let's say, if you rely one DLL on another DLL, it creates a circular dependency, which is not recommended. Since this is C language, you can literally code everything in not very secure manner and basically destroy your whole system. Yeah, and also like just now when we are in this this part. So since DLL have their own stack region, so let's imagine that if you call another DLL, it will load another stack, and you keep on stack, and you basically overflow it. Yeah, so it's quite fun. Try it, hack yourself, but do it in a VM. Don't do it on your host. So yeah, so basically there are certain guidelines Microsoft recommend in order for you to how to really utilize a DLL main function. Yeah, and you can try it by compiling. Here's the compile command, and yeah. And then next we will take a look at. So now we take for the code for the DLL. Now for the loader. So the loader is this file. Source file. Okay. So any questions? Questions? How do I go back to questions? Can you no questions? How do I go? How do I? Oh, Q&A. There I go. Yeah, no questions. But clear. Code for the DLL. Yeah. Okay. Now we will look at the loader. The loader is basically how to load the DLL. So for those doesn't have a code editor like Microsoft Visual Studio, you guys can read for the slides. It's the same. Okay. So over here, yeah, you have okay. In order for you to use the exported function from the DLL, you need to declare a type definition. And then just now, when we refer the DLL, we have three functions, right? But here I only use two. So yes, you cannot use all the functions in the DLL. And basically, think of it as a library. You don't pinjam all the books for the library, right? You just pinjam one or two books. Yeah. This is C code. You have your main function and you have a string of hello from exe, printf. So a question for you guys. If I run this, okay, wait. So, okay, here we have, okay, here we have add, process, and get string, and their main, right? And the question here is that once I run the loader, this file, what will be print first? Is it hello from exe or hello from DLL? DLL. Yeah, really? DLL? That's it. No, actually, it's exe because you run the loader first. But never mind, later when we run the program, you will notice how it works. Basically, how it correlates. Yeah. And going back, you have okay, before to load the library, you need to know the name of the DLL. And there's a particular search order the kernel will do, and it will search where the DLL is located at. And once you declare the name of the DLL, you use H module. Yeah, this is Windows. They have their strict rules how to use their own data types. And then you use the function load library A for the variable DLL name. And for this part, if it doesn't, if the code can't find where the DLL locate, it will return an error. If it works, you can get the get proc address. So get proc address, H here is referring to the module of load library A, which means you're using this DLL. And once you get proc address, you can use either two ways, the function name or ordinal number. Ordinal number, we'll take a look how being used. Basically, it's like index, like pages. Like I said, this topic is at page 10, topic 2 at page 20. Yeah, index. And if it doesn't find the function, if the function is not found, it will return an error. So this is the first function, basically add function. So it takes two value, 7 and 5, and return the result, and it will print the result. And the next function is process data. The next function is process data, and also same way, it will get proc address. And if not, if the DLL doesn't contain the function signature of function signature of process data, it will return an error message, or it will take this string value. Yapare is the best hacker, and print the original string and XOR it, and then return it. Yeah. Then was also recommended to once you use load library and you free, just like how in C, if you're experienced in C, if you malloc, you free it. Yeah. If you don't free it, congratulations, you hack yourself. Yeah. And yeah, so we can try to run it. These two code. Wait. This is this one. No, I just use my. Okay, it's a downloads. Yeah. Okay. Okay, you can open your terminal, and okay, this now the question was, once I run the loader, cd simple loader. Oh, I need to bring it up. Sorry. Man, you guys can go to, if for those who got the materials, you guys can hit to the release directory and open your terminal and execute. How do I increase the? I hope you guys can really see it without any issues. The size, font, is everything is fine, right? Yeah. No, when bigger. Okay. Simple loader. Okay, now execute the exe. It will load exe, and then DLL loaded, and you click OK, and then it will execute add the function, and original string Yapara is the best hacker, and return the XOR string, and DLL unloaded, and then done. So yeah, that's later on you will debug it. I mean, do static first, and then we will debug it. So yeah, clear so far? Are you guys following on? Those two with the materials? No issues, right? For the materials, yeah. So this is how DLL works. Now 9:30, I'm on track with my time, and now we understand the PE file format of DLL. So PE file format you can I mean a lot of tools that can do the same thing, PE Web, PE Studio, CSF Explorer, but for easier explanation, I use PE Web. And file load PEs, REDLL, downloads. Release, simple DLL, open. Okay, so like how the structure of DLL is similar as a normal executable exe. At first, you have your DOS stub, which is a legacy, and your PE signature, and you will have the important thing here is the file header. The file header that's able to differentiate an exe versus DLL. So especially at the characteristics section. So let's go to file header, and if you notice here, 200 here signifies that the file is the DLL. So if you remove this 2000 hex value, it will become an executable. And I've tried it, basically changing DLL to exe, and yes, it works, but you need to patch it. Yeah, it's a lot of fun. How to understand? Basically, since we have declared DLL main, right, and you basically ask the loader to execute DLL main rather than finding main. Yeah, then you patch it and then you run it, and then after you patch and run it, you put it back in IDA, and IDA will just get confused, and you will look at the export table. The DLL main will be in export table, and it's been saying that this is the entry point. Yeah, because normally in IDA the main will be the entry point. So it's quite fun. Play along with it, break stuff, and yeah. So the important thing here is that the characteristics, the value of 2000 defined is the file is DLL. And then if you refer MSDN characteristics PE header, it will show the file format. DLL characteristics. Yeah, characteristics. Go up again. So here we can see, here are the information, like just now the characteristics, the value there. And here in Microsoft documentation, here it says that image file DLL 2000, and saying that the image file is a dynamic link library. And that's when the loader know this file is DLL, and it's need to be executed in a different order. Yeah. Going back to the slides. Yeah. And then optional header, and yeah, optional header, you will notice a bit different. You have your export directory, RVA, and base relog. So generally that's how exe and DLL is different in terms of the structure. The rest are the same. The header, the rich header, the DOS header, everything's the same. Just the file header and optional header. And you have your relog. I mean, exe also have their relog. Yeah. And here we have, okay, bear in mind, a DLL also can rely on another DLL, since our DLL just now will execute message box, right? So message box is a function that's relying on user32.dll. And you see here, message box and user32.dll. Yes, there are there will be a case where another DLL rely on another DLL. So done with the PE section of okay, all right. So for this part, questions? Any questions? Oh, lag. Which part lag? I think I tutup camera. Okay. So which part I like is now? Or you guys want me to repeat? Make it big, little big. Is there any part that you guys want me to repeat? Because I'm going a bit too fast. Okay, all good for now. All right. Okay. So any questions? Let me check that. All good for now. Okay. So here we can also use tools like Dumbin. Dumbin basically is from the Microsoft tools. If you head down to x86 related tools, basically this is from Visual Studio Code, the tool, the IDE that we use just now. Here the command prompt, and head back to the downloads directory, user downloads, flat downloads, and main release. And over here, I'm just going to use two examples. Knowing the export function of a DLL and the dependence of the loader of an exe. So basically it relies one way on another. So Dumbin exports simple.dll. Here you get to know what are the exported function of the DLL. And here we can see a tree. Like this now I said the ordinal number, right? Basically basically refers like an index. And here get string, add and process data. So here the get string is a bit weird because this is the signature when you compile, because just now when we are using the callback function. So callback function will be compiled in a way where it's more easier to read for Windows application. So especially for run DLL32. So if you run DLL32, and then you DLL, wait, what file? Okay, simple DLL, and then since here's the ordinal number, right? You can use hash to the arguments to pass it for run DLL is with a hash and with the number of the ordinal. And once you run it, it will say DLL loaded, hello from DLL, which is the get string, and DLL unloaded. But if we run the one that's not using a callback function, it won't be loaded. So you will return the failure message. Yeah, you won't. Let's say add. Yeah, it won't execute because when we refer back to the code, DLL function for the add, it takes in 2 arguments. For run DLL32, when you parse arguments, it needs to be in a callback function. Yeah, and there's a guide or blog where they he really like discuss how run32 DLL can be used in order for you to really parse arguments. But it's really recommended for you to use callback function, and the return type must be always and void. So yeah, which I really explain in here. Yeah, in the dynamic analysis part. So that's another, I mean, that's too far away, but never mind. Okay, so now we can move to static analysis part with IDA. And okay, for the slides, from this point onwards, everything is just image. So I mean, this is my first time using Markdown format to use it as my presentation. And I find it hard to, put text below it, because this is an image. When I put text, it just runs away. So it's just learning how to center a diff again. So let's open IDA. Okay. So at first we're going to analyze statically for the DLL, see how it, what are the information that we can extract differently from an EXE. So far clear? Okay, all right. So once you open this DLL, hold on, give me a moment. So once you open IDA with this DLL, simple.dll, and you go to the export function, and here this is where it stores the information of the function to be exported. So as usual, the entry would be part of the main entry point, and here add along with the ordinal number and the address. And you notice here just now, like just now I said, run DLL when you want to use a function to be exported along with certain arguments. It needs to be called back so that it knows what are the values being expected to receive from run DLL32. But I will refer the block so that if you guys want to understand how run DLL32 being used, and also in run DLL32 is a default Windows application, and it's being you can say it's being abused as well, because it's part of the LOL bin, what's LOL bin stands for? Chrome len of wait, LOL bin. Sorry, living off the LAN binaries. Yeah, and then run DLL32. Yeah. That's, and attacker won't just like this now when we observe the example, the attack chain, right? Sometimes APT will just like drop one DLL and have a PowerShell that execute run DLL32. Yeah. And yeah, when we try to take a look at entry point first, and if you have your decompiler, you can hit F5. It's decompiling, drag it here on the right side, and synchronize IDA view. Okay, so here, like this now, when the code, we only execute message box A, and they are loaded, basically the string here, they are loaded and they are unloaded. And for add function, it will return an operation of addition, process data. You can notice the XOR function. This is for loop, and being XOR with the value of 6F, and get string would be here, return a message box with a text hello from DLL. Yeah. So also message box basically is just compiled along with it so that you can use with it. Like it's now when I say, it relies on user32.dll. This is what I mean. Okay. So generally that's how it works. And if you head down, if you open up this wider and you head down to the R data section, read only section, you will notice okay, in the R data at this specific address ends with a 2500. You will notice the export address table, and it's being defined at get string and process data. And below it is also have the ordinal tables for which functions being used. So basically, it rely on the DLLs R data in order for the EXE to being used the exported function. So yeah, debug information, yeah, nothing much. Basically, static analysis of DLL is nothing much. Just I'm showing you how it's being different from an exe. And when it comes to DLL, the name itself is dynamic. You need to run it dynamically to understand the behavior. So yeah, and we can now proceed with debugging it. Yalah, apa ni? Oh, lah. Okay. So far clear? For static, lol bus, ya. Lol bus or lol bin. Sama kan dua. Ya. Referring back to here, yeah, the image same. And now we're going to be moving to dynamic analysis. But since we have a loader, can I open my camera? Okay. Since we have a loader, we can just debug along with the loader. And yes, it's possible to run with DLL32, but just now we have only included functions that require arguments. So in order for the functions to pass arguments to run through the DLL, it needs to use this kind of function declaration. The rules are return type must be void, callback, and using Windows handle arguments, having a handler instance and command, because you execute run DLL in command line, what are the command line arguments being passed through. So yeah, and it's also best to use with Win API. Yeah. So X32 debugger, pause my time, 48. Okay. So I should wait for appearance. I need to change the font. 12, 12, 12, 12, 12. I mean, don't worry, guys. I won't be talking a lot of assembly code, but I will open up both IDA and X32 to show you the relation of it. Wait, before I load debugger, let's take a look at the exe. We haven't load the exe on IDA yet. So okay, I mean both files are 32-bit, not big an issue. And once you load it, you will at the start section, and I purposely compile in a way that you guys can't find the main function. If you control F main, it's not there. Well, how do you find the function that executes main? This is where your PE file format knowledge comes in. I mean, thanks to Aslan. Aslan is MCC, last year MCC instructor. He really advised me, no file formats prior to understanding static. Doing your reverse engineering, because studying PE file format, F file format really helps knowing which section store what information. So at this, like here an example, we don't know where main locates, right? If you open up CFF Explorer, CFF, okay. So CFF Explorer is also another PE parser. If you head down to optional header, and the important thing to know where the text section starts to execute is basically the address and the image base add with section alignment. So over here we have calculator. Let's use calculator. So here we have let's say image base, the base of the image, and the section alignment. You add these two values together. So here is a 400,000 plus with 1,000. So this particular address is where main locates. So if you get it back to IDA, and then here is it. So here, and then once you decompile it, press F5. and I just move it again. Okay. So here you can see that hello from exe, the string of hello.exe is there. And you guys can rename this function, rename global item, main, yeah. And then once you rename it, yeah. And then that's where, yeah, it's just the same code as just now. You have your string copy, and then functions to get proc address, load library, yeah. And we will be referring side by side along with the debugger. Okay. So okay. Before you guys load the debugger, make sure your options are click entry point, user DLL entry, and user DLL load. And you guys can also click unload, but I generally don't. But make sure to click only have these three options, and so that's easier to analyze and step through. And open files, downloads, clear so far? Questions? Idea is to locate start text to find the code. Idea, what idea? Idea is to locate start to find the code. For the image base, is it? Image base plus the alignment. Yeah, image base, when you add with the alignment, that's when okay, let me just, so IDA basically it mimics how memory it mimics how the executable being loaded in the memory. So when you scroll up, it's basically 400,000 x. It's also one way lah. And if let's say the address are all jumbled up, I mean, I don't know whether you guys use Ghidra. Does Ghidra do the same thing? I don't use Ghidra. And yeah, basically, if you scroll all the way up, it's also one way lah. There's different ways to find out how you can. I mean, if let's say this is a pack executable, right? It will be different address. It's not. It will be different. So finding the which particular address that the code the text section executes, that's where you need to know your PE knowledge. Yeah, clear? Clear? Okay. Okay. Where was I? Oh, debugger. Okay, so for those who have debugger X32, you guys head back again to release, and yeah, much better, much clearer. Okay, so here it's at the optional header of address of entry point. And going back to IDA, if you put it side by side, here we have call, and then look at the breakpoints, call stack symbols. Okay, so notice here, if you look at the simple loader.exe, the debug, I mean, now is the time is 9:55. It's fine, right? If we drag it. Okay. Like I said just now, DLL only execute when it calls. So if we look at here at this point, synchronize, and the assembly instruction is push AX load library A. And if you go back here, and then we I mean use bigger. Okay, go to the symbols tab and head to kernel32.load library A, and you will see the instruction here, load library A, right? And hit a breakpoint. No, hit breakpoint here. Hit it after. So hit it after, which means load library has been successfully executed, which means the DLL will be in the memory. And to check whether the DLL is in the memory, you can also open the symbols. And you notice here are the only DLLs are in the memory. And there's another tool you can use, procmon. And by referring to the kernel, the PID, the process ID of 10,824. For my case, yours should be different. Just refer the top one. Insert 10,824 and then click OK. Yes. And then once you hit, let me check. Okay. And then once you hit the breakpoint, simple loader. Okay. It loads the image. Okay. And then breakpoint, it's not hit one time. Kernel 32 enable CPU. And then here is the here is the optional header. And we are entered the simple DLL memory. I mean, basically this now is where the DLL is being loaded into it. The second breakpoint is when we after call load library, and you notice here DLL is being loaded, and these are the related DLL required to run along with simple DLL. So and then you can notice that hello from exe prints out first. And here, since we are in messagebox.dll, since we are in simple DLL memory region, you can hit a breakpoint at call message box, and then another message box, and yeah, okay. So these two message box, one would show DLL loaded and another DLL unloaded. And if you hit and then press F8, yeah, DLL loaded. I can close this. Yeah. DLL loaded. And next, I have to click cross and then next. Breakpoint deleted. Okay, F8. Okay, F8. And now we are in user 32.dll. Wait, why it doesn't execute? Call execute. Okay, loaded. Yeah, and then unloaded. Yeah. So here, once just now we were in the DLL's code of load library. So load library is now, it will only execute DLL main. And once we are after DLL main, it will enter back into the loader. So we press F5. And we continue. Breakpoint. Symbols. We set a breakpoint at optional load library get proc address. Now next we set a breakpoint at get proc address. Get proc address. Okay. Here we are calling for function get proc address. Okay. So breakpoint, we just remove a message box. Remove. Okay. Reload again, and now we are get proc address. So get proc address. If we hit F8, you'll notice that what's the value being passed? Oh, I went to the kernel. CPU. Okay. Okay, now we rely on IDA. Okay. We rerun back again. Enable. Now here we are at call simple loaders 64FF. Okay. Okay. Going back again. Basically now we are trying to find back the get proc address for the exported function. So 4F144. Basically, this is the not the same address in here. Basically, it's randomized because of ASLR. And if we call push EBP, okay. So here main, if we notice push EBP, move EBP, 6F, 6F, 4F144 call, and your symbols. Now we are at the entry point. Now we are at the optional header address of entry point. And then if you go back to CFF Explorer and you load the loader and you find the address of entry point, which is this, and this is the value, right? So 1444 is the address of entry point, and you can 1444, yeah, same. So in order for us to find the main, basically at 4, here is in the absolute address is 40, but over here is 4F. So it's pretty clear that we can straight away jump to 004F 1000. Yeah, and here you can notice the assembly instruction: push EBP, move EBP ESP, and sub ESP 50. So here's the prologue, and referring back to the assembly in the debugger is the same. So hit a breakpoint and run. We are in main, and we want to take a look at the get proc address, which is at address 1097. So looking at 1097, you can hit a breakpoint here. And also, yeah. And then hit run. Here is the loader. Hit run again. We are in a simple, okay. Simple, simple DLL. The entry point of simple DLL. And then if you scroll, here is a simple DLL, and then you can go to symbols, and you can place breakpoint as well. You can place breakpoint for, let's say, add toggle breakpoint and process data toggle breakpoint. And here we have two functions. But now we at this stage, it's only when the loader has only called load library A, not get proc address. So load library A only calls DLL main. So going back to CPU and hit next, and here we can see loaded. Okay, and then loaded, we just now on top, just now was in DLL. Now we come back into the loader and hit next again, and you'll see get proc address. Get proc address into add, right? And going back into DLL. Is it clear so far? Have you been noticing the changing of the memory room base? Okay, if you guys notice that the exe switch of exe and DLL back and forth, so that's how it works. It only the DLL only being used. That's what is meant by dynamic. So yeah, and here we can step through. Now in the DLL, we can hit F8, move EBP. Now here now is a stack frame for the add function, and you can notice the value. Oh, where's my? Oh, I lost my. Yeah, okay. Okay, I lost my. Okay, I need this. Okay, so just now when we move the value EBP plus 8, EBP plus 8 is 7. Just now in the code we see the value 7, and add EBP plus C 5, and then now if you press F8, pop EBP, return what's the value? 7, 12 should be where? Return 12. I don't see the value 12. Yeah, oh, okay, yeah, I said it's EAX. Yeah, C is 12 in C in hex is 12. Okay. And you return when you hit return, you return back to the loader. Yeah. Notice here the loader? Yeah. There you go. It switches back and forth. That's why it's just so beautiful analyzing DLL. Yeah. And you go down and then get prop address. This is for this is just a string. Oh, process data. This is process data. And once you are in here, you can step into it. And you're in kernel and hit next, and you're in DLL again. So you see this now when you notice this now when we step into the get proc address, it jumps into kernel and then only DLL. EXE doesn't directly jumps into DLL. There's a kernel being helped to switch the transfer memory. I don't know what it calls, but basically you can see how it switches the control flow. So from exe to DLL, and in between is the kernel. And the process data, what's the time now? Okay, 10. Okay, I need to go fast. Okay, process data, basically stack frame, and the string will be in ECX. Hit F8, F8, and ECX sort of string the value. Yeah, basically the value. And hit F8, and you notice jump. This is basically the for loop. So you can see it's jump. Yeah, it's now in the code we see some for loop. Yeah, XOR, and straight away jump. Yeah, unloaded, and finally everything's executed. So yeah, so far that's how you. Sorry, I'm going a bit fast because we need to look at the challenge. Okay, so basically I'm just going to show how it switches back and forth with the EXE and the DLL. So far, clear? Clear? Okay. Wah, banyak coy. Anjing. Okay. Sorry. Okay. Now we're gonna take a look at, okay, for those who participated BlackBerry CTF, yeah, the challenge that we're gonna look at is the helper.dll, and it's a bit different. You don't have to you don't have to code your own loader. You can just run DLL32, and I'm just gonna demonstrate how we're gonna do it. So yeah, here's the slides. Also, yeah, okay, yeah, okay, yeah. Okay, let's go. So first of all, at first, just now someone asked about the address part. Is it clear just now? I mean, how to find the main. I mean, it doesn't always have to be main that starts the code of the. I mean, basically think of it that where the kernel, basically the loading at exe, should know which address to start with. So PE really have this information ready for the loader to know, hey, this particular address that's where you're gonna start. So if you when you use IDA and you don't notice the function name main, you basically need to do a manual calculation, finding the base address and the image base, and add with the alignment. Yeah, alignment basically for the memory. Yeah. Okay, clear. Okay. Okay, now going to CTF challenge review. Okay, open with IDA first. And it's 32-bit. And yeah, I compile this differently. Basically, this DLL is not I crafted from scratch. It uses Merlin C2 agent, but it's not connected to any C2 agent. It's just I just use their function signature. So if you go to Google, so Merlin C2 DLL agent, and you refer to their documentation. A moment. Okay. Okay. So their DLL have multiple entry points, right? You have run, install, and white func. And then going back to, let me just close a few applications. Go to save. This window. Go to save. Annoying Windows. Okay. Okay. Yeah, going back to IDA, and if you notice your exports, yeah, when you statically analyzing DLL, the only thing that you want to know is that what exported functions could be used for another application. So over here, you can ignore TLS callback. That's just for the kernel. And the one thing that always will raise curiosity when you're doing malware analysis for DLL, you need to pay attention where functions, exported functions that has ordinal number, because this will be used along with run DLL32, right? So we can do, we can look at, we can decompile a code. So here run, press F8, F8. Why is it not working? F8. Okay, see, oh sorry, not F8, F5. F5 to decompile, and you drag and drop, synchronize it, and you will notice, okay, this is their entry point. It's not what I want. Let's run. Okay, so here basically is a message box, and when you click here, basically it shows a string, click OK to delete file, like it's not here but somewhere else, and you can try it. Here is okay. Yeah. On DL32, the DLL name, the file name for DLL is helper.dll. Sorry, I have to go into release. Run DL32, helper.dll, and the exported, referring back to the ordinal number, it's 1, and you can hit, it needs a hash and 1, and it comes out a notepad. But why does it come out a notepad? Why? I mean, over here in the code it says only return a message box, but yes, it did return a message box. Like it's not here but somewhere else. Does anyone have a clue why notepad executes when we hit run? Any idea? Okay, let me just tell you guys. So just now, like just now I mentioned, DLL has their own entry point, which is their main. And if you notice here, there's another function, and basically it will execute the notepad. If you search for the string, next notepad. Yeah, notepad will be called in a weird way, and so that it will able to execute the notepad. So for this DLL, whenever you run it, it will execute notepad, and based on the question, for the it has a function to call notepad. Yeah, that function to call notepad is somewhere hidden in the DLL main. Yeah. So DLL main, it will call once you load the library. It will always call DLL main. So actually I forgot to mention this CTF, the question of it. And if you go to my challenge, and basically the challenge name is reflective hidden agenda. And Sam, the question here says that Sam, a gamer struggling to level up, stumbled upon a mysterious DLL named Helper.dll in a gaming forum. And the post claims it enhanced gameplay, but Sam's skeptical. After loading up to VT, yes, I literally upload to VT, and zero detection. And Sam to decide to test it, loading the DLL into the game. It launches Notepad, and he realized the DLL, some part of it starts to wipe itself. So yeah, there are a few critical information that we need to extract first. It launches the notepad, and some parts of the DLL starts to wipe itself. And yeah, we need to find the flag. The flag is in this format. Yeah. So I can post this in here if you guys want to refer the question. Okay. Now let's dive into another function, export function. So just now we have to look at run. Run just basically just shows up a message box. And what func, there's a lot more. And here we can see, here we can, basically I want to copy the whole code and notepad. Okay. We can remove this one. What func? Okay, so basically we have a few key information here. We have message box. How to increase font? Yeah. View zoom. Okay, zoom in, zoom out, zoom. Okay, control plus. Okay, all right, better. Okay, so at first, for this is for void func function, you have the message box. Patience, I'm extracting the flag, passing a flag. And then over here we have the function, Windows API function, find resource, load resource, and log resource, size resource. So this, if you look at this tree function and you Google about it, it will shows you that this would be function to extract data from resource section and then use for another purpose. So if we open up CFF Explorer again, open the challenge file. Sorry, this is gonna take a bit of time because this challenge is medium level and only one team solve it. And yeah, if you hear just now I mentioned that find resource, log resource, right? So basically there's something in the resource section of the PE, and you resource factory, and it's not a good example here. So basically that there's data there. Wait, hex view, hex editor, relog. I can't see, but anyway, basically there are some payloads hidden in the resource section. So what resource section normally being used is that whenever you have an application, let's say a system application, and mostly being used where you can store different languages or different images being used within the application. So generally that what resource directory will store all this information, and it will be leveraged by attackers to store shell codes. Yeah. So here, after the size of resource, we can see an array of value, and then with 32, and then we can see malloc and also another function. So what this function does is that it's basically decrypting the values here and XOR. Yeah, XOR. Wait, is it XOR? Let me check that. Should be XOR. Yeah, XOR. So this value here basically is the key XOR the encrypted shellcode contained in the resource section, and then return it back. And that's where you need to find that's where you can able to decode it. not decode it, you find the flag. And going back here, you can notice the while loop here. Yeah. So after it performed decryption, the V3, it stores the size of the shellcode, and it begins to replace with 0, basically empty the memory that stores the shellcode. So basically, like just now, the question says that it starts to wipe itself. That's what I mean by, basically clearing up the shellcode. Yeah. So that's the static analysis of the code. Now we can debug it, find the shellcode, and need to use a shell debugger to extract the flag. So running out of time. 22. Oh my god. Let's do it. Hopefully in another 8 minutes. Clear so far? Okay. You guys are keeping on. No questions? Yeah. Questions? No. Clear. Great. Okay. 8 minutes to debug this. Okay. Let's go. Speed run. Okay. Run to it. X32 debugger. And okay. You guys need to not attach helper.dll, but attach run DLL32. So run DLL32 for the 32-bit is at Windows. Syswow 64, and then you search for run DLL32, which is this. Okay, this is the 32-bit version of. I know the naming convention is a bit like you thought syswow is 64-bit. Yeah. Anyway, Windows being Windows. Okay, and then here you have to change command line and make sure your command line are at this you have to pass the arguments like this now, the suggested from the recommended flow of running DLL. And then okay, and also remember your options. Go to head preference, hit entry breakpoint, user DLL entry, and user DLL load. Save it. And now we are in run DLL32. Hit next. You're in run DLL32. Hit next again. You're in helper. Notice here helper.dll. Okay, and we want to jump into the void function. So now next step, hit to symbols tab. Click on helper.dll. Okay, I know I pre-done my analysis. So okay, click into void func and hit a breakpoint here. And basically you need to hit another breakpoint after the shellcode being decrypted and before it being 0. So basically the sweet spot of hitting the breakpoint is at the sweet spot. Basically this is the function of decryption, and this is the while loop of being emptying out from the memory. So basically at this region. So basically when you run the DLL, only at these two address the decryption of shellcode will be in the memory. So here is 6B. Okay, at this, if I can do my maths well. Okay, now 6. Wait, now is DLL. Hit breakpoint. Where's my breakpoint? White func. It's enable. Hits 0. Hit next. Okay, hit run, and now you are in white func function. So here, okay, white function push ABP. So push ABP is at the address 17096E. Okay, now we are at referring to 6E 661709. Here is 6EB. Okay, and go here. Okay, we can click Control G and X32 debugger. 6E 6617. 6E6 1 6E6 66B 4181 F upper 81 6 B. Okay, 6 4181 F. Not the same. 66. Okay, yeah. Okay, sorry. Okay, yeah, it's a bit. You want to calculate? It's a bit difficult. You should use a calculator. Okay, now at this point we after the I reset I've done my pre-analysis. Okay, so basically we need to set after this address. Which address? 817. So over here 817. Yeah. So this function would be the decryption, and hit next. Make sure I'm extract the flag. Okay, now it's been here, and now I've really rely on T2 debugger. Hit F8. Next. Okay. Which is I'm trying to extract the flag. Okay, white func. I need you. Okay. Hit next. Flag. Okay. So here, after this here, we are stopped at the decryption function. F8 would be helper.dll run. Okay, so here we have the address dump. Okay, so ECX will store the value of the address where it decrypt, and then here is the EAX. Okay, before I show you. Okay, so basically what if you notice here, the function of the decryption, it will return the size. So the size will be stored in EAX. Size here, the size here means that how many bytes. Here is in hex value, and 10 sorry, the calculator, and we change to hex. 104 is 260 bytes. So over here we have 1 byte, 4 byte, 8 byte, 12, 16. So 16 per row. So those so going back to decimal, standard 260 divided by 16 equals to 16 and a quarter. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and a quarter until here. And what you do, you right click and you go to binary and save the file, save it as shellcode. How do I know it's shellcode? Because there's like observable strings like get proc, load library, and then like here flag. Yeah, there you go. And you save it and run shell debugger. CD desktop, and there you go. You get your okay. There's a flaw in this challenge. Since I have resolved, basically I consulted Farid from Kaspersky. I show him this challenge after the event, and basically he noticed that I able to resolve the Windows API, and he asked me why not you just execute shellcode. Yeah, so there's a bit of flaw, even though it's no one solved, no one, I mean, not no one solved, only one team solved it. It's not a great challenge because by right, you need to execute the shell code. Yeah. So that's where you give a malware to an experienced malware analyst. They know it's a shit malware and a good malware. So this is a very bad malware because I cannot able to resolve the shellcode. So here is the message box, and then here's the flag. Yeah. So that's the challenge, and yeah, that's it. Clear? Yeah. Any questions so far? Yeah. Okay. So to wrap it up, okay. So yeah, I've listed the steps here: export function and while loop. Yeah, clearing out EAX. Okay, inspect memory was contained. Yeah. So basically, only after the decrypted shellcode is only appeared to address. I mean, not to address, to assembly instruction, and the rest will be starting to be zero. Okay, the starting. Okay, I haven't showed when will we become zero. Okay, let's quick one. So over here, message box, blah 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 blah, and jump let's be helper. My IDA. That's my IDA. The while loop is at 844. Okay, 844. Let's go 844. Okay, yeah, here, and you can bring this down, and you can see a lot of jump instruction above. This is a bit annoying. I can't bring it down. Bring it down. Okay. All right, 844, which is here. Okay, and okay, I want you guys to look at the memory region. Okay, this is really annoying. Okay, yeah, this is the memory region where the decrypted shellcode will be, right? And okay, here 844. Did I place a breakpoint 844? No, I didn't. I did not. Okay. So jump not equal to 0. Okay, then it will jump back. Okay. So I hit next and pay a close attention at this region. It will become to be 0 every single time I execute. You see, 0, 0, 0, 0, 0, 0. So basically, this is the while loop that's working. Yeah. So basically, it's trying to be evade detection. Yeah. Acha malware. Yeah. So that's the while loop doing its job. Basically, clearing up the shellcode. Yeah, byte. Yeah. So that's how it works. And yeah. So that's the end. And this is me. Basically, when it comes to EXE, it's a bit boring. Slowly, a bit to be boring for me, and that's why I prefer DLL. So I hope you guys learn, how to properly analyze. I mean, it really depends a lot of dynamic debugging. Yeah, and there's a lot have to be. I mean, yeah, there's references. These two videos you guys can refer. This is more towards development, CPP-Con. And for CactusCon, it's more on really analyzing, and the speaker really explain different techniques threat actor used to deploy the malware using DLL. And MSDN is your best friend for developing Windows application, root library, and get proc address. And I will add another one more for the run DLL arguments, passing arguments to with for run DLL. So yeah, so that's all about it. And if you guys did all this while, thank you so much.